Hi students, in this video I'll be going through the 2023 Fall Express A Math WA1 question 3. Alright, so as you can see, this is a question regarding the R formula. Alright, so let's read the question. Okay, given that P equals to 2 cosine x minus 5 sine x, express P in the form R cosine x plus alpha, where R is a positive constant and alpha is a cube. Alright, so let's start the question. So they say let P, right, expressed in the form of R cosine x plus alpha. Okay, so this is what we're going to do. Okay, we're going to let 2 cosine x minus 5 sine x be equals to R cosine x plus alpha. Okay, then we're going to use the R formula to open, the addition formula, okay, to open up the right side. So we'll have R cosine A cosine B minus R sine A sine B. Alright. Okay, so this is the addition formula for cosine. Okay, so now we're going to do some comparison. Okay, so over here you can see that there's a cosine x and a cosine x already, right? So the cosine x has already been matched. Okay, so this means that R cosine alpha will be the 2 in front, right? Okay, so what we can write is R cosine alpha equals to 2. Alright, then let's compare this sine term. Okay, so you can see the sine x is here, sine x is here. So this means that this R sine alpha will be the 5 over here. Okay, so R sine alpha is going to be 5. Okay, so from here we can then find R and then alpha. Okay, so R is actually quite standard. R will always be the square root of the sum of the square root of the sum of the square of these two numbers. So 2 square plus 5 square. Okay, so 2 square is 4, 5 square is 25. So 4 plus 25, you get square root 29. Okay, so for the R formula, you can actually leave your answer in sub form, right? Okay, then from here, we can see that sine alpha. So if we do R sine alpha over R cosine alpha, so based on the numbers we have, it will be 5 over 2. Okay, then R will cancel off. Sine alpha over cosine alpha will give us tangent alpha. Okay, so that is how we arrive at tangent alpha equals to 5 over 2. Okay, so we will do a tangent inverse to find the base alpha. Okay, then alpha you should be able to get 68.20. Okay, to 2 decimal places. Okay, so once we have found alpha and R, we can then write out the P already. So P is going to be equals to, okay, in the form R cosine, right? So R is the square root 29 cosine x plus 68.20. Okay, so this will be the answer for part 1, right? Okay, let's move on to part 2. Okay, so part 2, they want us to find the values of x when P is equals to 3. Okay, for x between 0 degrees and 360 degrees. So over here we have the equation P equals to 3. Okay, previously we have already in part 1 we have expressed P in the R formula form already, right? So you have square root 29 cosine x plus 68.20 degrees equals to 3. Okay, so whenever you want to solve a trigo equation, you need to adjust the range. Okay, so the angle here is x plus 68.20, so we will adjust the range accordingly. Okay, so the initial range given to us is x greater or equal to 0, less than or equal to 360. Okay, but now our angle is x plus 68.20. So we'll add 68.20 to both sides. So the range now that we want to find is from 68.20 all the way to 360 plus 68.20, which will give us 428.20. Okay, so later on when we search for the angles, we will search from 68.20 to 428.20. Anything that's outside this range, then we will not take it. Right, so the next step to do this would be to bring the square root 29 over. So we'll get 3 over square root 29. Okay, then we are going to find the basic angle now. So we'll let alpha be the basic angle. So this alpha is not the same as this okay? This alpha represents the basic angle. Okay, 3 over square root 29 So the basic angle will be cosine inverse this 3 over square root 29. You end up with 56.145 degrees. Okay, so this will be the basic angle. Okay, so now let's go and search for all the possible angles for x plus 68.20. Okay, so let's search for all the angles. Okay, so cosine is now positive, right? Okay, cosine is positive, so we will go for the first and fourth quadrant. Okay, so if you take a look at this, the first alpha is here. Okay, so if we take the very first alpha in the first quadrant, right, you find that the answer is just 56.145. Okay, because the general angle is now equals to the basic angle in the first quadrant. So you can see that it's not inside the range because we want to search from 68.20 to 428.20. So 56.145 is actually outside the range. Okay, so we wouldn't take this angle, right? Okay, so we can't take this angle, then cosine is positive, so the next possible angle will be in the fourth quadrant where over here is alpha. Okay, so we want to take this one. So 360 minus 56.145. Okay, this one will definitely be inside the range. Okay. Okay, so then you need to ask yourself, is there a second answer or not? Okay, you will realize that there is. Okay, in fact, the question gives you a clue. They say values of x. Okay, so okay, we can actually make use of the first diagram over here. So if the first angle in the first quadrant that doesn't meet the criteria, right? Then what we can do is we can go one extra round and then come back here. Okay, so that will be 360 degree plus 56.154. Okay, so we are still searching in the first quadrant, but then we go for the second round. Okay, you notice that this one is actually within range because we are going to find x plus 68.20, right? Okay, over here is 360 degree plus 68.20. So we only added 56.145. So this will still be in range. Okay, so to find the value of x, all you need to do is bring the 68.20 over to minus. So 360 degree minus 56.145 minus another 68.20. So you end up with your first answer of 235.7 okay, to 1 dp. Okay, then the second answer will be 360 plus 56.145 minus 68.20. Okay, so you should end up with 347.9 degrees. Okay, so this will be one decimal place. Okay, so your two answers will be this. Okay, 235.7 degree and 347.9 degrees. Right. Okay, then let's do the last part. Okay, so for the last part, we want to find the maximum and minimum values of p squared. Okay, so if you recall, p we have expressed in our formula form, so it's square root 29 cosine x plus 68.20. Okay, so this is just a cosine graph with an amplitude of square root 29. Okay, so if you were to sketch out, it's going to look something like this. Okay, okay, with the amplitude of square root 29, that means the maximum point will be square root 29. The minimum point, okay, is going to be negative square root 29. Okay, this one has no vertical shift. Okay, so that means the center point will be 0. Okay, okay, so based on these values, okay, so that means we can select any value of p, right? Okay, from negative square root 29 to positive square root 29. Okay, so which one when I select and square it, because now they want p squared. Okay, when I select any of these values, I square it, I will get the maximum p squared. Okay, so that will be quite obvious, right? You can select two values. Either you select square root 29 or negative square root 29, you square. Okay, because both those answers will give us the maximum value of 29. Okay, then the next part, minimum. Okay, this is something that we seldom come across, right? Okay, minimum p square. Usually they ask us for minimum p only. If minimum p, it will be negative square root 29. But for p square, you need to think carefully. Okay, for p square, because you are squaring the number, even if you put in a negative value of p, right, you square out, you will still get a positive answer. Okay, so which value of p from negative square root 29 to square root 29 you put in, you will get the smallest possible value. So we know that when we are squaring a term, so p square, the smallest possible value you can get is 0. It's either 0 or a positive number, right? Okay, so in this case, it's quite obvious that 0 will be the minimum p square. Okay, but what value of p will you select to square to get 0? So of course, we'll select this 0 square lah. Okay, so p0 square, you will get 0. So the minimum value of p square is actually 0. Okay, so this one not too difficult of a R formula question. Okay, the first part actually quite standard. The second part not too difficult to solve. It's basically just like solving a normal equation. Find the basic angle, then search the required quadrants. Okay, so only the last part is slightly different.